base salaries.
Hello all. Hope you all are able to hear me. So let me quickly ask this question on are are you all able to see the screen and hear me? This would be my first question. Please answer to this poll on yes or a no. Yep, there we go. Please can you do that? Wonderful. 98% of y'all say yes. That's first poll question. Second poll question is, since you all are able to hear me, and let me ask the poll question here. Are you all able to, okay, or let me put this. Did you all get LMS access? Yes or a no? Please can you respond to this? Okay. Mm-hmm. Roughly 20% of y'all haven't received is what you're saying. All right. So just give me a minute. Sorry. Okay. So I just tried to get a confirmation. So we shall do one thing. I'm going to add another layer of escalation here so that the remaining people also do not face any issues. So here we go. Please forward the email that was sent to prasad at 360digitmg.com to my email ID, digitmg.com. Right. So I will highlight this because if despite this you haven't received, then I need to personally look into it and I will ensure that you all get access. Yep. Okay. So there are a lot of people who will be joining in basically in some time, but please resort to this. If check whether you fill the attendance form, application form. If not, then check your promotion tab in Gmail. It should be there. If it is not there, check your spam folder. If not, drop an email to Prasad. Okay, if he's not responding, or if he hasn't responded yet, then I would be the final level of escalation for you. And yeah, when things come to me, it's a little different. So please drop an email to me and I will ensure that immediate access is provided, and I'll also look into why it was missed out, if at all it was missed out. All right, faculty members, and I believe there are a handful of students also who have enrolled. I think we should now get started. So even before we get started, yeah, sure. Uh-huh. So what we have done is, if you open the learning management system, once again, this question will come up on, I'm not able to see the screen, I'm not able to hear you, your screen is blur, multiple things. So once again, just to prove you all, it's worth spending this time to avoid such messages in future, because I'm using a high-end internet connection and I'm using a noise cancellation headset. If at all there is any internet issue would be at your end. It is Mbps, right? It's 88 Mbps. Upload speed, 92.56 download speed. All right. Hope that clarifies. And no more questions, please, on internet connection is slow, etc. Yeah. Okay. So Enoch, can you post the YouTube link quickly?
I'll do that, buddy.
Yeah. So yeah, Dr. Satish, you'll have to do that. But then we actually posted it here. If there we go. It's also sticked in the sticky note so that it doesn't get, you know, by oversight. So Jyotsna, then what you have to do is you have to forward the email that you sent to Prasad to me, Bharani at 360digitmg.com, and I'm going to provide you with access. I'm going to provide you with access. Yeah. We will check on why it wasn't given. Okay. So no other questions, please, Chandra. You will load no ultimately, right? If you're joining only for certificate purpose, it's a different thing, Chandra. But if you're joining for knowledge purpose, let's focus on that for now. Oh my God. So what happened, Padmaja? Unable to read it. Okay. We would have asked you to fill the LMS access application form. If you have done that, then please check your promotion tab in Gmail and also your spam folder. If you do not see an email, then please drop an email to prasad at 360digitmg.com. If Prasad did not reply to you in 24 hours time, then you can send an email to Bharani at 360digitmg.com and we will ensure that access is provided to you. Is that clear, Padmaja? Is that clear, Prasad? Okay. So now aispry.com. The moment you log in to aispry, okay, you would see this specific program there. Okay, you'll have to click on this, click on my courses, click on this trainer or whatever your login is, click on that and click on my courses. The moment you click on my courses, you would have learning management system orientation. If you want, look at that. How to use learning management system, everything will be there in that. And also there is training orientation. And this is the program that you will see. AP State Skills Development Corporation and 360 Digit MG Faculty Development Program on AI and Deep Learning. When you see this, I repeat, you click on this. After you log in, after you enter your username and password, when you drop down on this, you will see an option called My Courses. Once you click on My Courses, this is step 1, this is step 2. Once you click on this, you would see this program. You will have to click on this. This is step 3. Once you click on this, you would see all the modules which are available. And within each module, you will have the training slides. You just click on that and click on next, next, next. You will see all these slides. And also you'll have a quiz which is available. Click on that quiz and take the quiz. This is for your own practice. Clear, my dear friends? Yeah, exactly, Anil. People who did not receive an email, first send an email to prasad at 360digitmg.com. Send an email. If you did not receive an email, send an email to prasad at 360digitmg.com. Everyone, please, if you didn't receive LMS access, send an email to prasad at 360digitmg.com. Please send an email. Please send an email to Prasad. I'm repeating despite that you're putting on the chat window. Please don't. I mean, it will waste our time. Please, that's a request from my side. If you did not receive an email, LMS access, despite sending an email to Prasad, then send an email to me. And dear team from 360 Digit MG, please start taking those questions. I think if they don't understand, you can do a private chat and then just let them understand on what to do. Okay, now let's proceed further. All right. So here There are 4 sessions which are available for the 4 days. Today is the 5th day. I'm sure, Enoch, we are YouTube live now. I'm sure, right? Enoch? No worries, Jyotsna. You just drop an email. If you're not able to find, drop an email to Barani at
Yeah,
360DigiTMG.com.
YouTube is live
Yeah,
as well.
wonderful. I wasn't able to see here, so I was just checking. Okay. All right, then let's proceed further. No, you cannot enroll for any other programs. Okay. Enoch, just ensure that you check with Prasad. A few of them are not seeing the right access. A few of them are seeing additional courses, I think.
I'll take care of it.
Yep. Yeah. And I think we should get started now because a few of them are like get lost. So let's get started with the training. So this is the mind map link. I do a drop down and say AI and deep learning. Let us understand on what we have discussed until now. So we started off by understanding about project management methodology called CRISP-DM, which stands for Cross Industry Standard Process for Data Mining. Okay, and then we understand the business problem. We record the objectives and constraints. Once we record the objectives and constraints, we proceed further with the next step, which is data collection. Even before you proceed further with data collection, you should be aware of the various data types. We discussed about all of these data types: continuous, discrete, qualitative, quantitative, so on and so forth. Then you collect the data. When you collect the data, you have primary data source and secondary data source. Once this is done, you proceed further with data collection. We proceed further with data cleansing. Data cleansing, data preparation, data munging, wrangling all mean the same. And you perform exploratory data analysis, feature engineering, all of these. And I always recommend that you read this mind map at least once a day so that you get better understanding. And then we need to venture into data mining, machine learning, wherein you have supervised learning. Within supervised learning, you have supervised learning is also called as predictive modeling or black box technique, right? And we have unsupervised learning and reinforcement learning. Go to look at this. We have neural networks. Okay, within this, we have a lot of things that you will learn. And then you have unsupervised learning, all of these things. And then you have reinforcement learning. And also we have model evaluation techniques, which is machine learning, bunch of these, and model deployment. And also we have touched upon Python to get a basic understanding. Today also towards the end, we will just briefly look at that. After mathematical foundations, we will have deep learning primer, and then we will get started with our first machine learning algorithm or first deep learning algorithm called multi-layered perceptron. Okay, so let's get into mathematical foundations. If I go here, we are now into module 3, mathematical foundations. You can just do a next, and then you'll be able to process this. Okay, but even before that, what I shall do is I will open the PPT, the same presentation, just that I'll have a better control because we have certain animations available here. Mathematical foundations is extremely important for you to become a good expert. Okay, for this, I need to pull up optimization. We'll just look at optimization related mathematical foundations, which is good enough for us. What is optimization in the first place? To help answer that, let me take this example of FedEx. FedEx is a logistics firm. Do you know what? Millions of daily shipments must be individually sorted and routed to the correct general location, usually by aircraft, and then delivered to the exact location in an amazingly short period of time using a motorized vehicle. What does this mean? Say I'm going to send a parcel to Malaysia. In that way, different people will be sending parcels to different countries. Maybe someone is sending from India to US, so on and so forth. Maybe you're sending to Australia. And you send all these parcels through a company called as, say, FedEx. What would FedEx do? It will have millions of daily shipments. And they have to ship using aircraft and using your vehicles, whatever other motorized vehicles, your van, truck, maybe bikes, whatever be it, two-wheelers, etc. So here, the optimization would be, how do I ensure that each and every parcel reaches the end person, end customer on time? Okay. And for that, they put an optimization function or objective function, which would be maximize on-time delivery. Okay, you want to maximize on-time delivery or within this SLA. If they say within 24 hours, you will receive your parcel, within 24 hours, we need to receive. And then we also have constraint. Constraint is that you want to, you will be having minimum aircrafts. Maybe you have only 10 aircrafts. And maybe you have only 1,000 vehicles, motorized vehicles. So given these constraints that you have only 10 aircrafts and 1,000 vehicles, how do I maximize the on-time delivery? This is called as a typical objective function. If you look at a company called as Fifth and Company, which is a beef meat packing plant, it has customer service representatives who talk to more than 8,000 customers. They talk to more than 8,000 customers daily. How many people should work in the day shift? How many people should work in the night shift? How many people should work in the afternoon shift over a period of next 28 days? So here you want to optimize or maximize the resource utilization. Okay, when you want to maximize the resource utilization, you want to also at the same time minimize, the number of people working or escalations that happen, so on and so forth. Xerox, State Oil Hydro Challenge, US Federal Aviation Administration, Netherlands Airways Challenge. All these are using, including Indian Railways, including your aviation sector in India or elsewhere, they use optimization techniques in a big way. And hence, we keep saying that whenever we need to write the objective function or constraint function, right, business objectives or business constraints, business objectives or business constraints. Whenever you want to write these business objectives or constraints, we need to ensure that to the extent possible, we use the terms minimize or maximize. To the extent possible, if you're not able to do that, then that's fine. Despite that, if you're not able to do that, but we need to do it. Minimize the travel time, maximize the code coverage, minimize the downtime, maximize the user satisfaction. Okay. And then you have profit. Profit is equal to revenue minus expenses. So profit is simply put a function of revenue and expenses. So you say y is equal to x1 minus x2. This is how you can write a mathematical function for profit is equal to revenue minus expenses. All right. Now let's do this. Find the average rate of change of a function f of x equal to 4x minus x square. What is the average rate of change for this? What do you mean by rate of change in the first place? Okay, so let me write it down here. When I say rate of change, or when I say derivative, or when I say slope, or when I say gradient, all of these mean the same. Rate of change, derivative, slope, gradient, all of these mean the same thing. Okay, all of these mean the same thing. Now, if I simply, if I were to explain you rate of change, let me draw x-axis and y-axis. And here, you might have 1, 2, 3, 4, 5 in that way. 1, 2, 3, 4, 5 numbers. Here also you might have numbers 1, 2, 3, 4, 5 in that way. 1, 2, 3, 4, 5 in that way. You might have numbers. Now if I say x is 2 and y is 3, you'll plot it, or let me say, yep, let me plot here. When I say x is 3 and y is 2, you plot it here because you have x is 3 and y is 2. You plot it here. And then you join them. So what does this mean? This means that if I change x from 2 to 3, y is changing from 3 to 2. So if I increase x on one side, y is decreasing. So there is a negative correlation, right? So there is a slope in the negative direction. The rate, if I, for example, if I increase the price of movie ticket by 100 rupees, what will happen to the demand? Will the demand drop or will the demand on the contrary increase? Right? So that's called as rate of change. Now, if I have this function like this, right? Profit is equal to revenue minus expenses. So y is equal to x1 minus x2. I'm saying x1 is revenue, x2 is expense. In that way, there is say some equation which is formed here. F of x equal to 4x minus x squared. And also remember y is equal to f of x. This is very important. Okay. Now, if I take x2, x equal to 2 and substitute in this equation, you'll get f of x, that is f of 2, x equal to 2. You substitute 2 here. So it will be 4 into 2 minus 2 square, which will be 8 minus 4, and you get 4. Now let's look at this f of x plus delta x, meaning you're increasing this to 3. So f of x is 2 plus delta x is the change. Change will be from 2 to 3, 1. So plus 1, which will be nothing but f of 3. So that's 3 here. So now let me substitute f of 3 in this. So it'll be 4 into 3 minus 3 square, which is nothing but 12 minus 9, which is going to give you 3. So here we have 4, here we have 3. So if I were to solve this equation, it will be f of x plus delta x will be f of 3. F of 3 will give you 3 as an answer minus f of 2. F of 2 will give you 4 as an answer divided by the change in x is 1. So this will give you minus 1, meaning if you increase x, y decreases. Hence you have a minus sign there. This is simple stuff and it is called as rate of change. A few other preliminaries, very important. Rate of change, once again I write it here. Rate of change or slope or derivative or gradient. All of these mean the same. That means how are you changing your x? And if you're changing your x, what is the change in your y? If you change x by 15, y changes by 24, for instance. And you also have this rate of change. For example, if you have a point here, a single point. For a single point, there won't be any change on x-axis and there won't be any change on y-axis also because it's a single point. It's not moving from here to here or it's not moving from here to here. It's the same point. So the slope or derivative or gradient or rate of change for a single point is always undefined. Okay, it is always undefined. And there we go. So y plus delta y minus y divided by x plus delta x minus x. And that means change in y plus delta y means this number. Okay, y is this number. From y to delta y, what is the change? When you change from x to delta x. So that's change in x. If you change in x, how much is it going to change when it in terms of y? That's what it is, change in y. So this is fine. Now let us get into a few foundations, elementary foundations. These come in really very handy, my dear friends. So when we look into deep learning algorithms, you will never be confused. If you understand this, there is no way that you will get confused. Okay, so let's understand this. So you have d by dx of x raised to the power n, which is n into x raised to the power n minus 1. So if I have a function like this, x raised to the power 4, then what do? This is like x raised to the power n. Okay, so you write it as n into x raised to the power n minus 1. That means it is 4 into x raised to the power 4 minus 1. And 4 minus 1 is 3. So you get 4x cubed. And one more very important thing is, as I've told you, y is equal to f of x. And you have f of x here. If you want to find the derivative of this with respect to x, you can either give a notation as d by dx of this x raised to the power 4, or you can also give a notation as f prime x, that's derivative of this, or you can simply, because y is equal to f of x, you can give a notation as y prime. all these mean the same. So y f prime of x is equal to 4 into x raised to the power 3. And if I have an equation like this, y is equal to x raised to the power 8, then what do you think will be the derivative of that? Yep, y is equal to x raised to the power 8. Apply this power rule and let me know on what will be the answer. May I request everyone to respond? May I request everyone to please respond on this? Y is equal to x raised to the power 8. What will be the derivative of this? Quickly, can you all please respond? Let me see. Wonderful, wonderful. A lot of you all are responding. Wonderful, and you are also getting it right. So this is like x raised to the power n, which is again n into x raised to the power n minus 1, which is nothing but 8 into x raised to the power 8 minus 1. 8 minus 1 is 7. This is exactly what you get. Y prime. Then we also have constant multiple rule. If c is a constant and f is differentiable function, then you have here, which is d by dx of cu, which is equal to c into du by dx. Whenever you have a constant, you take out that constant in this way and you find the derivative of the remaining function. And if you have d by dx of c x raised to the power n, c is a constant, so you take it out, and x raised to the power n, derivative of that is n into x raised to the power n minus 1. So let's solve it. It's already solved, by the way. So d by dx of this can be written as 7 into, because this is a constant, you take it out, d by dx of x raised to the power 5. And derivative of x raised to the power 5 would be, this is like x raised to the power n, which is n into x raised to the power n minus 1, which is 5 into x raised to the power 5 minus 1, which is 4. And you get 35 x raised to the power 4. Then we also have summation rule, wherein we have d by dx of u plus v, which is du by dx plus dv by dx. Okay, and here, when you use this equation and solve it, this is u and this is v. This is u and this is v. So when you solve it, it is derivative of this, right? And how do you get it? Derivative, you find the derivative of this x raised to the power 4 plus derivative of this. Yep. What shall I say is the answer for this, dear faculty members? What is the derivative of this going to be? Please, can you let me know? Let's see. Take quick 30 seconds and can you answer? Okay. So let me quickly glance. Wonderful, wonderful. A lot of y'all are responding. Wonderful. And do you know what? Interestingly, All these are the right responses. All these are the are extremely valid and right responses. Yep, great job. So let me also help you with this. So here it is similar to x raised to the power n, which is n into x raised to the power n minus 1. So you get 4 into x raised to the power 4 minus 1, which is 3, plus derivative of this is 12 into d by dx of x raised to the power 1. This is like cu, constant and u, right? You bring out the constant and find the derivative of this, which is 12 into derivative of this is 1 into x raised to the power 1 minus 1. 1 minus 1 is 0. And x raised to the power 0 is 1. And you get 12. Okay, so it's 4x cubed plus 12. This is the derivative that you get when you solve for this. And that is exactly what is given here. And as I've told you, derivative of this, you can write it as d by dx of this y, or you can denote it as f prime x, or you can give a notation as y prime. All of these notations give you more or less the same answer. And if you have the derivative of a function like this, right, then, and if you have an equation like this, then what will be the answer? Come on, can you all answer this? I'm sure you can. Let's see. Let us see on whether you're going to get it right or wrong. Okay. So I'm seeing that you all are almost getting it right. Okay. Right. So here, if you find the derivative of this, derivative, you have to separately do this. Okay. So you'll write this as d by dx of x raised to the power 4. You have a minus sign, so minus d by dx of 2x square plus d by dx of 2. So when you find the derivative of this, it is like x raised to the power n. That means it will be n into x raised to the power n minus 1. So you write 4 into x raised to the power 4 minus 1, which is 3, minus, this is like cu. So if you have a constant, take out this constant. So it'll be 2 into d by dx of x square. D by dx of x square plus, remember what did we discuss earlier? Derivative of a single value would be undefined if you have a single number. So derivative of that would be 0. Okay, so derivative of this constant will always be 0, and this can be written as 4x cubed minus 2 into, this can be again treated as x raised to the power n, which is n into x raised to the power n minus 1, and you have x square. So n is 2, 2 into x raised to the power 2 minus 1 is 1. So it is 2x. Minus 2 into this component derivative would be 2x. So it'll be 2 into 2x, which will be minus 4x. Let us see on whether we are getting the same answer or not. Wonderful. It's 4x cubed minus 4x. So we are almost getting the same answer. Okay, and these things I would just skip because these are not These are important, of course, but we will learn about that later. So I'll just skip here. Yeah, this is important once again. If you are given a product rule, that means if I were to find d by dx of ux or uv, two functions, multiplication, then you say u into dv by dx plus v into du by dx. Say we have a function like this. You treat this as u, and you can treat this as v. U and v. Then how do you solve it? Very simple. U into dv by dx. So this is u, x squared plus 3 into derivative of this part, d by dx of 2x cubed plus 5x plus v, which is 2x cubed plus 5x into d by dx of x squared plus 3. So this can be written as x squared plus 3 into, you find the derivative of this. Derivative of this can be written as again u plus v. So you first find the derivative of this, right? So it will be d by dx of 2x cubed plus d by dx of 5x plus 2x cubed plus 5x into, again you write it in this way, d by dx of x squared plus d by dx of 3. Again, how do you write it? X squared plus 3 into, this 2x squared can be written as 2 into, I'll write it here, d by dx of 2x cubed is nothing but constant into your variable. So take out this constant. So it'll be 2 into d by dx of x cubed. And this x cubed would be written as x raised to the power n, which is n into x raised to the power n minus 1, which is nothing but 2 into 3x squared. This will become 3x squared. 3 into x raised to the power 3 minus 1. So this is mathematics 6x squared. Okay, 6x squared plus. This part is finished. We solved this. Now let's solve for this. This would be like d by dx of 5x. Again, this 5 is like a constant. So you take it out. So you get 5 into d by dx of x raised to the power 1, which is nothing but 5 into, this is like again x raised to the power n, which is n into x raised to the power n minus 1, which is 1 into x raised to the power 1 minus 1, which is 0. So x raised to the power 0 will give you 1. So you get 1. So plus 5 plus 2x cubed plus 5x into, you have d by dx of x squared. D by dx of x squared, which is nothing but, again, this is like x raised to the power n, which is n into x raised to the power n minus 1, which is 2 into x raised to the power 2 minus 1, which is 1. So into 2x plus, for this constant, you get a 0. You might feel it is a lengthy derivation. However, it is not at all lengthy, right? It's a simple application of this product rule. That's it. Very, very simple. Very, very straightforward. So let me erase these and show you the answer. Once you practice once or twice, you'll feel that, okay, it is pretty simple, pretty easy. But these things you need not do it manually. Your Python will automatically do it for you. But then you might ask me, then why are you solving it? I'm solving it because I need to explain you about how deep learning algorithm works. For that, these things are extremely important. Okay, and then if you have a quotient rule, d by dx of u by v, like this, How do you write it? This component is called as U, and this component is like V. Okay, so you have U and V. So how do you write it? You write it as V into du by dx. So this is V, x square plus 3 V into du by dx. So d by dx of 2x cube plus 5x minus u. U is a numerator. 2x cube plus 5x into d by dx of v. V is x squared plus 3. By v squared, this is v. X squared plus 3 whole square. And when you solve this, you get an answer. Okay, so that's how we do it. Now, this is also out of scope. This is one of the most important rules when it comes to your deep learning. Very, very important. Now, until now, we have just discussed about foundations. We discussed about the power rule. We discussed about constant rule. We discussed about the sum rule. We discussed about the difference rule. We discussed about the product rule and quotient rule. These are the rules that we discussed. And here there is yet another rule called as chain rule, which is extremely, extremely important for you to understand deep learning algorithm. Remember, in the hierarchy of what are the salaries that people get, an AI expert gets more salary than a typical data scientist. Okay, so if I were to just give you a sense on how it works, so first you'll have a data analyst who will get the least of the salary. Then next comes your kind of data engineer. The next comes data scientist. And next comes AI expert. You're learning this, right? You're learning this. And the next to this would be your full stack data scientist who knows about end-to-end various things. Okay, in terms of salary, this is how it would be. In terms of knowledge levels, also it is the same, right? An AI expert is a person who is amazing. Data engineer is a person who also knows about big data, etc. and how to implement. Data scientist would build predictive models. AI expert will deal with videos, images, all sorts of data. They are very high-end. That's a high-end job. Okay. All right. Now, the next most important thing is, how do you find out whether a specific point is maxima or minima? For example, if you're looking at the profits, obviously, what do people want? They want to maximize the profits. So an aviation client might look at, how should I price the air ticket, price of air ticket, such that I get maximum profits. Okay, how do I price the air ticket such that I get the maximum profits? So what happens? Here you have prices of air tickets. You keep on increasing the price and the profits will keep on increasing. But if you increase the price beyond a point, no one will purchase, so your profits will decline. Okay, so if you keep on increasing the price from 1,000 rupees to 2,000 to 3,000 to 4,000, at some point of time, your price of a ticket will be the highest. Beyond that, if you increase the price, there might be no one who might want to purchase, so your profits might decline. At this point of time, at this juncture, at this point, you'll have the maximum profits. So you want to identify on what is that maximum value. Okay, first find out this value. Okay, and then decide whether it is maximum or minimum, because say you're looking at error that your model will experience, and say you're changing some kind of a weight in your machine learning algorithm, you'll have an option to change your parameter, which is also called as weight in deep learning neural networks. So you keep changing the weight, and you keep checking on whether the error is decreasing or not. So you keep changing the weight, keep changing the weight, keep changing the weight. After a certain point, what happens is, if you keep on increasing or changing the weight or keep on decreasing the weight, you'll keep coming to the bottom in this way. Or if you are here, you'll come in this way, right? But at some point, what will happen is you will reach a minimum value and then you'll start increasing. This is the value which you need to first find out. And then decide on whether that is maxima or minima. To find this value, simple way to look at it is slope. Okay. If you have a line like that, it will have some slope. Slope is nothing but if I change x by so much, by how much is y changing? If I change x by so much, by how much is y changing? That's slope. Okay, you'll have a slope for this line. And then if I take another plot, with x and y, and if I draw another line like this will have a different slope. This will have some slope. This will have another slope. My question is, if this is slope of line 1 and if this is slope of line 2, which will have less slope? Line slope 1 or slope 2, which will have less slope? Let me ask this question here and please answer to this. So question here is, which line will have less slope? Will it be line 1 or will it be line 2? All right, please answer. Please, can you answer? Which line will have less slope? Look at that, how steep it is. Just to ask on which line has less slope, think about this. If you stand here and start running, will you come down faster here or will you come down faster here? If you're coming down faster, that means slope is steeper, slope is high. If you're going to come down slowly, then the slope is less. If you come down on this slope, slope will be higher, right? This one, slope will be higher. Here, slope will be less because you'll slowly come down as opposed to this line. Wonderful. 80% of y'all are getting it right. Truly, that's an amazing thing, right? Y'all are getting it right. Yes. Now, if I say that I have a third line wherein I have a slope like this, which is parallel to x-axis. If this slope is parallel to x-axis, and if this is slope 3, then what do you think will be the slope of this line? Anyone? Let me look at your chat window. Which line will have, or this line, what will happen to it? What will be the slope of this line? If you're saying for slope 1, for this line 1 slope will be higher, line 2 slope will be slightly less. For line 3 slope will be what? 0. Absolutely, friends. Here there is no slope at all. So I would say slope is equal to 0. There is no slope at all. Wonderful. There is no slope absolutely. Right? That means at this line, at this point, if I draw a tangent, tangent means a line which just touches the surface of the curve. At this point where tangent and the curve intersect at a single point. Okay, at this point where the line and the curve intersect at a single point, this is called as critical value. Okay, what is this value called as? Critical value. Same thing here also. The point where this tangent and this curve will intersect at a single point, this point is called as critical value. Okay, this point is called as a critical value. Now, the next question that we need to ask is that critical value minima or maxima? Because at both these points, slope will be 0. Here also slope will be equivalent to 0. Let me choose a different color. Here also slope will be equal to 0, and here also slope will be equal to 0. Now for these two places, if the slope is equal to 0, okay, then which is minima, which is maxima? We really don't know on which one is minima, which one is maxima. So we need to find out that. Okay, and we are going to find out that first, and then we will take a break. Okay, let's complete this logically, and then we'll take a break. I understand it's an hour now. So for a change of x, if you keep changing x, and if your y value also keeps on changing, that means here if you keep changing the x value, your y value keeps on increasing, keeps on increasing, keeps on increasing, keeps on increasing. At some point it will reach the peak, and then it will keep on decreasing. This is called as maxima. Okay, and here you have x-axis and here you have y-axis. You keep increasing the x value, you keep on increasing the x value, you keep on increasing the x value, and then while your x value keeps on increasing, your y value keeps on decreasing, and after a certain point it starts increasing. The point at which it starts increasing is called as a minima. Now we know for a fact that wherever you have slope equal to 0, at these 2 points you'll have slope equal to 0, because if you draw a tangent, it will just intersect at that single point. Here also it's the same. And once again, what is a slope? Slope is also called as derivative or rate of change or gradient. So slope is derivative. So simply put, if I want to find this critical point, if I want to find this critical point or critical value, okay, if you want to find this critical value, you just find the slope. Okay, so you take the equation, say this is the equation of this curve or this curve. Then if you find the derivative of this, how would you find the dy by d of x? This is like x raised to the power n, n is 2. So it'll be n into x raised to the power n minus 1, which will be 2 into x raised to the power 2 minus 1, which is 2 into x raised to the power 1, which is x. But you have a minus sign, so you put that. So you get minus 2. But slope equal to 0 is critical value. And slope is nothing but derivative. So I'm finding the derivative and equating it to 0. That means I'm finding the slope and equating it to 0. And then I get x value. This is called as critical value. Either this or this. We don't know whether it is minima or maxima. But we know for a fact that this is your critical value. Then you just do this. Y is equal to x squared. Again, if this x raised to the power n, formula is derivative of this would be this. So you write it as derivative of this is equal to 2 into x raised n is 2 into x raised to the power 2 minus 1, which is 1. Equated to 0, you get a critical value once again. Now, to find out whether this critical value, so you have this equation, right? Y is equal to minus x squared. Derivative of y can be written as dy by dx or f prime of x or y prime. Okay, remember this. Very, very important. Okay, because here y is equal to minus x squared. So derivative of this is given this notation is equal to minus 2x. We solve this. And when I say this is equal to 0, which implies x equal to 0, if you take minus 2 on the other side, this is your critical value. The problem is we need to check whether this critical value is minima or maxima. To find out whether this is minima or maxima, what we do is we find the second derivative of this. Okay, you find the second derivative. Second derivative is take the first derivative and find the derivative of that yet again. Do you know what? If you do a second derivative, it is written as square y by dou x square or d square y by dx square. You're finding the second derivative, or it can be written as f double prime of x, or it can be written as y double prime. Y double prime, f double prime x, or d square y by dx square would mean that it's a second derivative. So this is your first derivative, and this is your second derivative. If the second derivative is less than 0, then your critical value would be maxima. Now once again, the other equation which we have taken was y is equal to x squared. Yep. Then you find the first derivative. When you find the first derivative and when you equate it to 0, you get your critical value, which is if you take x 2 on the other side, you get 0, which implies this is your critical value. Now, what do we need to find? We need to check whether this is your minima or maxima. You need to check whether this is minima or maxima, and then you also have your second derivative. And when you find the second derivative, if you get a number which is greater than 0, then your critical value is called as minima. Simple. Take the equation of the curve, find the first derivative, equate it to 0. You get a critical value. To determine whether your critical value is minima or maxima, you find the second derivative. If the second derivative is less than 0, critical value is maxima. If the second derivative value is greater than 0, the critical value is minima. That's it. This is how you solve it. Okay, wonderful. So I'm sure y'all are okay until now. So let's do one thing. Let us quickly take a break for 10 minutes and then let us come back. Okay, you all were saying that, hey, break really makes sense. Okay, we will do that. We will do that, Anil. So we will do that, Renuka. Okay, let's take a break and it's 11:40 now. Let us be back by 11:50 and then we will discuss more. So break time. Hey, hello, and welcome from the break. So we will discuss more. Sheikh, there are thousands of algorithms. Yeah. Okay. So what is Maheshwar's question? I didn't find any data set in LMS. We haven't started yet, right, Maheshwara Rao? When we start working on the projects on the data sets, then we will share it with you. Okay. As of now, we haven't started the first algorithm. When we start it, we will let you know. Right, Maheshwara Rao? Just bear with us, okay? We are just laying down the foundations now. And once the foundations are laid down, we will start with the algorithm. Yeah. All right. And we have a different way of sharing. We will also help you create your GitHub and then we'll proceed further. For that, Mallam Ekambar, you'll have to watch our recorded video. All right. And people are asking for WhatsApp group to join WhatsApp group. Okay. Now, this is a quick recap. Whenever an equation is provided, you will first find the derivative of that. And when you find the derivative or slope and equate it to 0, you get the critical value. Why? As I've already told you, slope will be 0. Slope will be 0 wherever your derivative is 0, right? Slope or derivative is the same. Slope is 0 means there is nothing which is changing. Slope, there is nothing which is changing, right? Here it is changing. Here also it's changing, right? Here also it's changing throughout, and here also it's changing. But at this point of time, at these points, it is not changing. Okay, then say you have an equation like this. My bad. And you want to find the critical value of this equation, and then you need to determine whether the critical value is minima or maxima. So first step is very simple. First step is find the derivative. Okay, find the derivative of this. How do you find the derivative? You just say derivative of this and equate it to 0. Derivative of this, we have already seen it. It's like x raised to the power n, which is n into x raised to the power n minus 1. So it is 2 into x raised to the power 2 minus 1, which is 1. So you have 2x. Here, you take this constant out and find the derivative of this. It is again like x raised to the power n, but here you have x raised to the power 1. If you don't have any, it's like 1. So this is n x raised to the power n minus 1, which is nothing but 1 into x raised to the power 1 minus 1. 1 minus 1 is 0. So 1 minus 1 is 1. So 3 into 1 is 3. And derivative of a constant is 0. When you equate it to 0 and when you solve it, you get critical value, which is 3 by 2. So 3 by 2 is a critical value. To check whether this critical value that you have found is minima or maxima, you do the second derivative test. That means you take this and you find the derivative of this once again. And when you find the derivative of this once again, you get this second derivative. Derivative of this is 0, derivative of this is 2, which is greater than 0. If it is greater than 0, second derivative, then is this critical value minima or maxima? Let me ask this question, and this should be kind of a poll question that we need to ask. So the poll question here is the critical value minima or maxima? Minima or maxima? Please, can you respond to this? Where is this? Yep, I'm speaking about this critical value. And I've already done the second derivative and given you the answer. So given this, is this critical value minima or maxima? Yep, can you answer? Absolutely. If the number is greater than 0, it implies that critical value is minima. If a number is less than 0, then the critical value is maxima. Okay, now say you have an equation like this. Once again, the same process continues. You first find the first derivative, okay, and equate it to 0. So you find the first derivative, equate it to 0. When you equate it to 0, you'll get two solutions. Of course, people who know about equations, they understand that this is 3x square because you're finding the derivative of this. This is like again x raised to the power n, which is n into x raised to the power n minus 1. So you get 3 into x raised to the power 3 minus 1, which is 2, minus, you take out this as a constant, 3 into this is again x raised to the power n, which is n into x raised to the power n minus 1, which is 2 into x raised to the power 2 minus 1, which is 1, into 2x. So 3 into 2x is 6x. Derivative of this is 0. So you get 3x into x minus 2, which is 3x squared minus 6x, equated to 0. When you equate it to 0, you get 3x equal to 0, and you get x minus 2 equal to 0. When 3x equal to 0, then x will be 0. And when x minus 2 is 0, you get x equal to 2. These are the critical values. Then use a second derivative test. Okay, first derivative, second. When you find the second derivative of this, how would you write it? You take out 3 as constant, and derivative of this will be 2 into x raised to the power 2 minus 1, which is 1. This is like x raised to the power n, which is n into x raised to the power n minus 1. Minus, 3 into this, which is 6x, minus 6 into, you treat this as again x raised to the power n, which is n into x raised to the power n minus 1. This is x raised to the power 1. So it will be 1 into x raised to the power 1 minus 1. 1 minus 1 is 0. X raised to the power 0 is 1. So you get 1. So minus 6 into 1, which is minus 6. Okay. That's the second derivative. So you have the first derivative and the second derivative. Now take the second derivative and substitute the first critical value in that. If you get a negative value less than 0, what does this imply? This critical value will be minima or maxima? Maxima. Okay. Now take the second derivative, substitute 2 in this. When you substitute 2 in this, you get a value which is 6 greater than 0. Okay, now greater than 0 means this critical value is maxima. So you get this value which is sorry, minima. My bad. Okay, it's minima. Sorry. Okay, so you get this critical value which is minima. All right. Until now, we dealt with an equation which has a single argument. When it's a single argument, you have only one x, which is called a single argument. Here also, we had a single argument called x. That's it. You didn't have anything else. You had a single argument. Actually, two arguments is out of scope. It is literally out of scope for this module. But then since a few of you all have asked for, hey, what if there are more arguments? How do I deal with it? To help you answer that, I will take the two argument case also. And when you have 3 arguments, 4 arguments, 100 arguments, the same logic, you just need to expand it. Okay. Once again, honestly, this is out of scope, not needed. It won't suit everyone. A few of you all want to know, hence I'm teaching you this, because we need to, at least from tomorrow onwards, get started with projects. Okay, we will be solving the projects. We will understand the business problem, and then we'll collect the data and we will get started on the projects. Okay, please pay attention. So you have multiple arguments here. You have x1 and x2 also. So you have 2 arguments. Whenever you have 2 arguments, the scenario changes. What do I mean by scenario changes? Until now, we found something called as derivative because we had a single argument. If we have multiple arguments, derivatives are given a different name called as partial derivatives. Okay, derivatives are given a different name called as partial derivatives. So partial derivative is written as dou. This is called as dou. Dou y by dou x1. You have x1 and x2, but I'm finding the derivative only with respect to x1. Hence it is called as partial derivative. Okay. Whenever you have a constant, derivative of a constant will be 0. So this will go to 0. And x2 will be treated as constant. So wherever you have an x2, 5 is a constant, x2 is a constant. So this derivative will go to 0. 48 is a constant, and x2 is a constant because you're finding derivative with respect to x1. So x2 will be constant. So this will also be going to 0. Now, if you find the derivative of this component, which will be minus 3 into, derivative of this will be 2x1. X raised to the power n, same logic. And here you have x square. So n into x raised to the power n minus 1. So 2 into x raised to the power 2 minus 1 is 1. So this component will be 2x. This is 3. 3 into 2 is 6. Minus 6x1. Minus 4 into derivative of this will be like x raised to the power n, which is n into x raised to the power n minus 1. This is 1 into x raised to the power 1 minus 1 is 0. So you get x. Sorry, 0. X raised to the power 0 is 1. 1 into 1 is 1. So minus 4 into 1 is minus 4 plus 2x2. 2 is a constant. x2 is also constant. What did I say? Since we are finding the derivative with respect to x1, x2 is a constant. 2 is anyways a constant. So 2 into this into derivative of this, derivative of any argument is 1. Okay, so because this is also like x raised to the power n, which is n into x raised to the power n minus 1. This is, if you don't have any, it is like x raised to the power 1, which is 1 into x raised to the power 1 minus 1. 1 and 1 minus 1 is 0. So this will give you 1. Okay, so this is called as partial derivative with respect to x1, treating x2 as a constant. Then derivative of equation with respect to x2. If you find the derivative of equation with respect to x2, it's called as what? Partial derivative. Because you have x1 and x2, but you're finding the derivative with respect to x2. So x1 is constant. Derivative of this will be 0 because constant. Since you're finding the derivative with respect to x2, x1 is treated as a constant. So this will also be 0. This will also become 0 because 4 is a constant, x1 is a constant. Why is x1 constant? Because you're finding derivative with respect to x2. Derivative of this will be 2x1 will be constant. 2 is constant, x1 is constant because you're finding derivative with respect to x2. And derivative of this will be 1, so it will be 2x1 minus 5 into derivative of this. Derivative of this will be, again, from now on, I think it will be easy for you all. It's x square. So it'll be 2 into x raised to the power 2 minus 1, which is 2x. 5 into 2x will be 5 into 2, 10, 10x minus 10x2. Plus derivative of this, here 48 is constant and derivative of this is 1. That's 48 equal to 0. Why am I equating these to 0? Because I want to find the critical value. We want to find the critical value. Critical value, and then we will decide whether that critical value is minima or maxima. Okay, so you equate it to 0, right? Find the first derivative, equate it to 0, second derivative, equate it to 0, and then you solve it. You take x2 on one side and shift everything else to the other side. So 2x2 is equal to 6x1 plus 4. Take it on the other side. Then x2 is equal to, you divide everything by 2. You get this. Take your time, 10 seconds. Understand how we got this. And the understanding is that you all are professors, doctors. So obviously you'll be knowing all these things. But maybe you learned about these things long back. So I'm taking the additional time to just ensure that I kind of do a thorough explanation. Okay, now we take this x2 and here we have two equations. Okay, this equation and this equation. I'm just here, I'm taking x2 on one side and remaining on another side, so that I take that x2 and substitute here. So you take this x2 and substitute here. When you substitute x2 here and solve for this, what do you get? 2x1 minus 30x1, 10 into this, minus 10 into 20 will be minus 20 plus 48 equal to 0, which implies minus 28x1. This will give you plus 28 equal to 0, which implies when you solve it, x1 equal to 1. All right. When I get x1 equal to 1, I'll substitute here x1 equal to 1. Then what will you get? x2 equal to 3 into 1 plus 2. Why am I putting 1? Because x1 is 1. You get x2 equal to 5. So the critical value is 1 and 5. That is what is given here. Now the question that we need to answer is this critical value minima or maxima or neither? Neither minima nor maxima. Neither minima or maxima is called as a saddle point. Within deep learning, this is a problem, saddle point. Okay, saddle point is a problem, certainly a problem. We need to see how to solve that. Okay, so what did we do? We just took the first order derivative and found the derivative of equation with respect to x1. Then we found the derivative of equation with respect to x2. This is given a notation f1, f2. Just notation. Why? Because yep, I need to build on top of this. So we found first order partial derivative. Now, when it comes to second order, you'll have two things. One is called as second order partial derivative, or one is called a second order direct partial derivative. Very, very important. Just please pay attention, and for the rest of your life, I'm sure you'll remember this. Okay, second order direct partial derivative and second order cross partial derivative. Okay, I will take a slight detour at this point of time because I want to tell you one thing which I heard recently. I heard this statement that world has money to pay. Okay, and companies also have money to pay. Companies also have money to pay, but they will pay you only what you are worth for. Simple. They will pay you only for what you are worth for. Okay, very, very important. There are a lot of people who expect a lot of money because according to them, they are worth more. But then companies also should feel that you're worth, right? It's not just you alone. Boast about yourself that, hey, pay me more because I'm worth more. Come on. Companies have to decide on whether you're actually worth or not. World has to decide whether you're actually worth or not. There is money. There is no dearth for money, but they will pay you only what you are worth for. Please remember this. And one more very important thing is, blink of an eye, there are new algorithms coming in. So you have to stay abreast of all the techniques. The training which I'm providing now covers all the algorithms until now. Trust me, 6 months to 8 months down the lane, there will be new algorithms which will be coming at each point of time. And it is our responsibility together to ensure that we learn those new things and we impart training to the students in that way. We have to make them realize that they have to keep enhancing their worth so that companies find worth in them. That's it. Simple logic. And one more thing that I've observed, that is, one interesting, analogy which I can draw here is, there was supposedly a guy, a person who had double leg amputation, meaning surgical removal of the legs because of accident. No legs, absolutely. And he had his upper part of the body, only upper part of the body, Just imagine that there were no legs until the thigh, right? This guy has scaled Mount Kilimanjaro, which is one of the toughest terrains, toughest mountain to climb in Africa. When people interviewed him and when they asked him, I mean, people with two legs, people who are extremely strong, extremely healthy, they find it very difficult to scale this mountain called Kilimanjaro. How could you do that? The only thing he told is that I'm sure there is a lot of hope, and I wanted to give hope to the people like me who do not have legs. I want to give hope to people who don't have legs, right? And he was telling that only one thing was in my mind, which was one step at a time, one step at a time, and one step at a time. That's it. By the time I realized I was at the pinnacle of the mountain, because I just believed in one step at a time and one step at a time. This is exactly what I request you all, faculty members and students. Okay, believe in one step at a time, one step at a time, and by the time you realize, you'll be at the peak. And also remember that, of course, money is honey for everyone. You all need good salaries. You all want to get into good colleges as faculty members. You want to do consulting, right? Because a lot of research fund is there, like Dr. Ravi was saying. There's a lot of research grants available. It's up to you on how to get that grant and how to make your students be part of that bigger picture. So for that, you need to increase the worth. And that is exactly what you're doing. And this FDP program is one step at a time. Because I see a lot of people will have differing mindsets on, okay, are these foundations needed? Without the foundations, how can you get to the peak? It's like this. Now we are just trying to climb up. But before we climb up, we want to know how steep it will be. What are the challenges that you'll encounter, right? What if the oxygen level drops somewhere here? All these things are very important. Okay. So that is where we are heading towards. So when you have multiple arguments, okay, when you have multiple arguments like x1 and x2, the first step is find the first order partial derivative, equate it to 0, and solve for x1 and x2. You get the values. To decide whether this critical value is a minima or maxima or neither, right? Minima or maxima or neither. Neither means saddle point. We'll discuss about that later. We need to proceed further with second order partial derivatives. When I say second order derivative, you need to do first second order direct partial derivative and second order cross partial derivative. So second order direct partial derivative is as follows. Find the derivative with respect to x1 and you find the derivative with respect to x2. Okay. And you're terming that as x1 and x2. Now, direct partial derivative means you once again, second order direct partial derivative means you take the first order derivative and find the derivative once again. So that will be dou square y by dou x1 square. And second order direct partial derivative would be take this and once again find the derivative of this with respect to the same variable or same argument. When I say cross partial derivative, you take this derivative dou square y by dou x1 into dou x2. You first found the derivative with respect to x1. Now find the derivative of that with respect to x2. And take this, find the derivative of this, dou square y by dou x2, and then find the derivative of that with respect to x1. x2 then x1, so cross. x1 then x2, so it's cross. Direct means x1 and x1, x2 and x2. This is how it will be. Second order direct partial derivative means find the derivative again with respect to x1, you get f double 1. Find the derivative of this with respect to x2, again with respect to x2. Okay, and then you have second order cross partial derivative, meaning find the derivative with respect to x1, then with respect to x2, x1 and then with respect to x2. Or you find the derivative with respect to x2 first, then with respect to x1. And according to something called as theorem, Young's theorem, this will be equal to this, meaning you first find the derivative with respect to x1 and then with respect to x2, or first with respect to x2 and then with respect to x1. Both of these will give you the same answer. Both of these will give you the same answer. This is equal to this according to Young's theorem if these two are continuous functions. Now, again, just to do a quick recap, what did we do? We found the first order direct partial derivative, first order direct partial derivative. We equated these two to zeros, solved it to get the critical values. Are these critical values minima or maxima? To find out whether these critical values are minima or maxima, the next step is you find the second order direct partial derivative, meaning take this equation and derive it or find the derivative of that with respect to x1 again. If you find the derivative of this with respect to x1, x2 will be constant. So this will become 0. This will also become 0. Then you'll be left out with only this, which is -6. Then you find the derivative of this with respect to x2, meaning x1 will be 0. This will also become 0. So you get -10. Now what you do is you also find out second order cross partial derivative. So you find the derivative of this and find the derivative of this with respect to now x2. If you find the derivative of this with respect to x2, x1 is constant. So this will be 0, this will be 0. You get 2. Then you take this and find the derivative of this with respect to x1. x1. Then x2 will be constant. Oh, sorry. My bad. I think I've explained it the other way around, I think. Okay. So take the derivative with respect to x2 and find the derivative with respect to x1. Now, when you find the derivative with respect to x1 here, am I a little confused here? Not sure. I was thinking about something else. Okay, fine. Fine. Just hold on. Sorry for that. Sometimes this happens to me. I don't know. I keep explaining. I keep thinking about something else, about a project pertaining to Coca-Cola. How is that going on? Oh my God. Right. Let me come back here. Okay. You have this equation. and you find the derivative of this with respect to again x1, then x2 will be constant. So this will be 0 and this will be 0. You get -6. You take this equation, find the derivative of this with respect to x2, meaning x1 will be constant. So this will be 0 and this will be 0. And derivative of this will be -10. Now take this equation, which is first derived with respect to x1 and then derive it with respect to x2. So x2 means x1 is constant. So this and this will be zeros. You get 2. Then here you take the equation which is first derived with respect to x2 and derive it with respect to x1. With respect to x1 means x2 is constant. So this will be 0, this will be 0, and you get 2 here. Okay, so I do this. So this is symmetry. Okay, now I will tell you on what do you mean by a saddle point. Okay, we need to now find out whether this critical value is minima or maxima, right? For this, I'm going to define the rule now. The rule is that you find the determinant of this determinant, wherein you take f11, f12, f21, f22. You cross multiply and subtract. So when you cross multiply and subtract, it's something like f11 into f22 minus f12 into f21, and always these two will be the same. Okay, always those two will be the same. Now this is called as determinant. So what will we get? Let's see. f11 is -6. f12 is 2. f21 is 2. According to Young's theorem, these two will be same. And f22 is -10. Solve it. Find the determinant. Cross multiply. -6 into -10 is 60. Minus 4, which is 56. Okay. Now pay very close attention. If d value is less than 0, which implies critical value. What did we get critical value? 1 and 5. How is it 1 and 5? We solved it if you remember. Found the first order derivatives, equated it to 0 and solved it. Okay. Now this critical value will be called as saddle point. What is saddle point? We'll discuss. Okay. It is called a saddle point. Means it is neither minima nor maxima. If your d value is greater than 0, then there are two things. Then you take this f11, which is called as a. Okay, f11 is a. Then if a is less than 0, one is greater than 0, another is less than 0. If you have alternating signs, it is your critical value is called as if. Okay, let me put it here. And a less than 0, then critical value, which is 1, 5, is maxima. However, if d is greater than 0 and if a is also greater than 0, then your critical value, which is 1, 5, is minima. Simple. So here, this a value that you see is -6. D value is 56. So d is greater than 0 and a value is -6. That means A value is less than 0. If the signs are alternating, critical value is called as maxima. So we just reached the maxima. Okay, and what is a saddle point? Saddle point means it's something that you put on the back of the horse. Okay, you put on the back of the horse. From one direction, if you're standing here, if you look at it from this direction, you'll feel as if it's a minima. But then if you're a person standing here, and if you're observing it from another direction, you'll feel that it's a maxima. So from one direction, you'll feel as if it's minima. From another direction, you'll feel as if it is maxima. This is called as saddle point. Okay, so that's what it is. What did we do? We took the first order derivative, partial derivative. We equated it to 0 to find the critical value. Then we found the second order direct partial derivative and second order cross partial derivative. Okay, and then what do you get when you find the first order partial derivatives? You get f1, f2. When you find the second order direct partial derivative, you get f11, f22. And when you do a cross partial derivative, you get f12, f21. Then take all these numbers, arrange in this way and find Hessian determinant like f11, f12, f21, f22 and solve it. And this f11 is called as A. And then write the condition. If D value is less than 0, then you need not look at anything. Then critical value is saddle point. If D value is greater than 0 and A less than 0, then critical value is maxima. If D is greater than 0 and A is also greater than 0, then critical value is minima. That's it. This is all we need to know to proceed further with our deep learning. Of course, if someone wants to read more, okay, this is all that you need to know. But people who want to do a deep dive, go ahead, slides are given. If you have more than two arguments, you need to find minor, cofactor, then use a Laplace transformation or use a Xiong crisscross method or Xiang method, and then find the values and extend it in that way. Find first primer, second primer, third primer, fourth primer, fifth primer, yeah, and then proceed further. I'm leaving it to you guys to explore. Those are there. Those slides are given. However, it is not in scope. I don't want to trouble the other people. Yep. All with me? That case doesn't occur vanilla. Okay. Just explore further. You'll understand more. And again, the same questions are repeating, and then we are getting complaints from the other people also. Okay, that same things are repeated again. Again, same questions. How do I get access to LMS? I clearly mentioned this. Everyone, please take a screenshot and please don't ask the same question again and again. I'm sure you all are, uh, very clear with this understanding. Let us all be on the same page. Read this, take 1 minute, and please don't ask me the same question on how do you get LMS access. It is very clearly listed down here. Take a screenshot and read it. Okay, no more messages, please, on how to get LMS access. Okay, I'm displaying this, please. That's a request. You're sidetracking all of us, all the participants, okay, and me also. It's not good. I'm already posting it, I'm giving it. Please take a screenshot. Please don't ask the same question again and again, because we have a certain flow to the training. You are constantly breaking that flow. Okay, this is a request, please, friends. I mean, we all are well educated. Don't do this, please. Don't do this. It's harming completely. Okay, and if you sent an email, I'm clearly telling that please forward that email to me. If you didn't get an access, I will personally help you guys get access. Despite that, what is the reason why you're sending that message? I didn't quite get you, because I'm in training, right? Post I come out of the training, I will help you guys. I should check my emails, right? Only after the training I can check. Come on, friends. Okay, after the training I will check. Forward it to me if you didn't get access. This is my email ID. What else are you expecting? I didn't understand. Yeah, please. I mean, it's really bothering. Even if you get any issues that LMS access credentials not working, first send an email to Prasad. First send an email to Prasad. If you're not getting any response, then send it to me. Okay, Prasad, and I'll personally look into it. I'm going to pull out some time. Personally, I will look into your issues and then I'll address those. Personally, I will do it. Trust me on that. But don't keep sending that message, right? If you have any issues, Prasad, if he's not able to resolve it, forward, escalate it to me. I will 100% look into it. A few of the professors contacted me saying that I sent email to Prasad, he didn't respond. Then I immediately jumped into action. I ensured that access is provided. Okay, please don't do that. I mean, it's really bothering and disturbing a lot, because the entire flow gets disturbed, right? That's the reason. Please drop an email, friends. Again, please don't, let's not sidetrack. Okay, let's take a break. I think we need a break, everyone. So it's roughly 12:40 now. Let us connect back at 12:50 and then take it further. Break time. Hello, everyone, and I'm sure you all are back from break. So let us do a quick recap. And with today's session, I think majority of the you know work pertaining to oops, mathematical foundations will be done, and will be good to proceed further. So this is a recap. Simply put, where did that go? Let me get to that page where we have a quick recap. Here. So simply put, take the first order partial derivative f1 and f2, equate f1 and f2 to zeros, f1 to 0 and f2 to 0, and solve for critical values. Solve for critical values. Then take second order direct partial derivative, which is f11 and f22. Then do a cross partial derivative, f12 and f21. Then find the Hessian determinant like f11, f12, f21, f22. Then when you cross multiply and subtract, you get 0. That's your determinant. f11 and into f22 minus f12 into f21. Sorry, I'm not saying it's 0. Fine. So you solve it. And if d value is less than 0, then you just hit a saddle point. Saddle point means from one side it will appear as if it's maxima, from another side it will appear as if it's minima. If d value is greater than 0, then you proceed further and check for this a value also. And if a is less than 0, then your critical point is a maxima. On the contrary, if d is greater than 0 and a is also greater than 0, then critical value will be minima. Then suddenly a few of our people who actually have given a good thought was saying, what if d equal to 0? If d is exactly equal to 0, then you cannot use a second order partial derivative to solve this. What people actually do is they resort to a numerical way of solving it. Numerical analytical techniques such as Newton-Raphson technique, etc. We can go with Newton-Raphson technique, or you can go with something called as Gauss theorem. Okay, and then solve it. Or maybe actually this technique is itself not right to solve. Okay, so as you all have requested, a few of you all have requested, that's a very valid point. Certainly, I'm going to ensure that the last 10 minutes is dedicated towards just answering your questions. Could be operational questions, right? We'll answer all of those. But then let us solve this. Not solve this. Let us understand a few more things about Python programming. Okay. And just to do a quick recap here, we understood about what libraries are needed. How do you define your functions or objects? How to refer to specific columns in a data set, right? And then how to import or load a data set into Python. and then how to use AND operator, OR operator, multiple operators, right? And then how do you create your own custom function? Okay, how do you create your own custom function, etc. How to make use of if else condition statements. Then how do you look at if else if and else conditional statements? What do you mean by range? Okay, and then how do you write a loop syntax? All these things we discussed yesterday. Today we will take this discussion further by looking at while loop, etc. Okay, and one more thing, or two things rather. Number one, how to learn Python programming. Any programming you will not learn if this program is given to you upfront. What happens is, if I give you this, all you will do is you'll select this line and run it, and the moment you see an output, you'll feel very happy. But you know what? You need to feel very unhappy about that, because you're learning nothing. Tomorrow if someone asks you to write a few lines of program, you cannot. You understood the logic, but you don't know how to write it. You'll be handicapped. Hence, the recorded videos are given to you all. Of course, we created a private channel for that. Not everyone will have access to it. People who subscribe will continue getting access to it. And look at that video and type it. Manually type it. Okay, that will make you perfect, and that is how you learn. It is a journey, friends. Like the example that I've given of the person who scaled Mount Kilimanjaro, whose two legs were amputated. Say on same lines, think as exactly like what that guy was thinking. One step at a time, one line of program at a time. Suddenly you'll see that by the end of this training, you'll have very good understanding. But do not run these lines as is, type and then run it. Okay, back to this. While loop syntax. We will start with I equal to 1, and I'm writing a while loop. While I is less than 10, while I is less than 10, starting from 1, print the number I and also do I equal to I plus 1. Okay, what did it do? It printed. Let me explain now. So while I is less than 10, you print I. So and you started initialized at 1. Is 1 less than 10? Yes. So print 1. Then I equal to, initially it was 1. So 1 plus 1 is 2. Then go back. Is 2 less than 10? Yes. Then print 2. Then go here. Then say 2 plus 1. Right? I equal to 2 plus 1, which is 3. Is 3 less than 10? Yes. Then print 3. Then go here. I is 3 plus 1, 4. Go back. Is 4 less than 10? Yes. So print 4. Keep doing this until you reach 10. The moment I is 10 less than 10? No, it is false. So your loop will quit. You'll come out of the loop. Okay. Sorry, the second thing was Python libraries, right? We need to quickly name those Python libraries so that you all understand it clearly. So we will have NumPy, which will be used for numerical calculations. Sorry, I keep writing this time and again because I just want to hammer these things into your brains. SciPy is for scientific calculations. Pandas is used for data manipulation techniques. Then you have scikit-learn or sklearn, which is a machine learning library. Then you have stats models, which is used for statistical analysis. Then we have matplotlib, which is for data visualization. Then you have Seaborn, which is advanced data visualization. Then you have TensorFlow, Keras, and PyTorch. All these three are deep learning libraries. And you have OpenCV, which is used for computer vision. Or image processing. These are the various things that you should be aware of. If you want to use Python for data science or machine learning or AI or deep learning, these things will help you address the issues very easily. Okay. Then I'm defining X here. Okay. And I'm saying X equal to this 1, 2 will be called as one element. Then 1, 2, 4 is second element. 43 is third element. 54 is fourth element. 2, 3, 4 is the fifth element. So I'll run this. You have all the 5 elements. Look at this. It says it's a list of 5. Then what you're saying is if I in X, so it will be like I in 1, I in 2, I in 3 in that way. If length of I is greater than 2, then break, come out. Else print this I. So if I run this, you'll understand it better. Okay. What happened? It printed 1, 2. Let's see. So here you have 2 elements. Here you have 3 elements. Here you have a single element, 1 element, and here also you have 3 elements. In total, you have 5 entries, 1, 2, 3, 4, 5. Within this, you have 2. Within this, 3, 1, 1, 3. For I in X, if length of I is greater than 1, so this will be I equal to 1, I equal to 2, I equal to 3 in that way. You just take length of, when I is equal to 1, it will refer to this. Find out the length of that. Length of that is greater than 2. Length of that is 2. This 2 is greater than 2, right? Oh, sorry, this 2 is not greater than 2. My bad. So it will not break. It will print the number. So it is printing this I, which is 1 and 2. Now, if you look at the second I in 2, length of 2 is 3. And 3 is greater than 2? Yes. So you break the loop. You came out of the loop. You didn't print it. This is how you write your break functions. Very, very important. When we actually start writing the program, it will help you more. And how do you create an empty container? You just say open and close braces. You is using assignment operator. You assign it to an object called A, and let me run it. Now you can keep appending. Append A dot append of 1. Run this. Do you see there? It shows 1. Then A dot append 1 comma 2. So what happened? It just added 1 initially. Now it has added 1 comma 2. Then if you say A dot extend of 1 to 3, again it added 1, 2, 3 numbers. It extended this. It's not adding these 3, 1, 2, 3. It is not adding those 3 as an element. First, what happened? You added 1. Then you told append this 1, 2. Then it added this as an element. When you say extend, it says 1, 2, 3. This is the difference between append and extend. Append means it will just take the entries, add it as a new element. Extend means it will just extend this 1, 2, 3 in that way. Next, data frame. Data frame, you can think about this as collection of multiple lists. List is what? A is a list of these numbers. I is a list of these numbers. X is a list of these numbers. In that way, data frame is collection of all these lists. So all I'm saying is pandas. So you need to import, right? You either say import pandas. If you just say import pandas, what you should have ideally done is here, you should have written pandas dot data frame. You should have written pandas dot data frame. But then you are importing pandas as PD. You import pandas as PD. So if you do PD dot data frame, you'll say PD dot data frame of, you have the columns. Columns you have A, B, and C. And you're assigning to new underscore df. Oh, I didn't import pandas as PD, so let me import that. NumPy also. Then here, you're creating A, B, and C. Let me run it. So here you have this new df, which has empty columns A, B, and C. You just created that. See friends, once again, if you're connecting from your mobile phones, you might find it difficult. I request, at least for this training purpose, you have to have a laptop or an iPad or pad, some kind of a pad. It'll be easy, right? Otherwise, it'll be taxing on your eyes. Okay, next. You're creating series of numbers. 1, 2, 3, 4, 5, 6. You're creating series of these numbers, panda series, and you're assigning it to column A. How do you refer to columns in Python? Okay, let me put that here. How do you refer to columns in A? Which one is correct? Let me put a quick poll question and see. I'll reset here and ask a question. So how do you refer to columns in Python? So do you say df dot, in this scenario is a df dot a, or should it be, I assume that it is df just to just not to confuse you guys. Or if it is df of a, or both of the above. Yep. Please, can you answer? Which one is the right way of referring to columns? Answer is both. Answer is both of the above. Yep, right. Both are the right answers. You can either refer to the columns using new underscore df, because that's the name of this data frame. You either say dot a to refer to this, or you say new underscore df within the square brackets. Within double quotes, you refer to a. Both will give you the same answer. Wonderful. So I'm assigning this to column A. Let me run this. And then if you go to this data frame, wonderful. 1, 2, 3, 4, 5, 6 are assigned. Okay. Now, if I say pd.series of A, B, C, D, I'm taking only 4. Here I've taken 6. Here I'm taking only 4. And then I'm assigning it to an object called B, or a column called B. When you do that, the remaining entries will say NaN. Does anyone know what is the abbreviation of NaN? I've already told you previously. What is the abbreviation of NaN? Can you all please resort to chat window and respond? NaN? Let me see. Exactly, that means not a number. Okay, NaN says means not a number. Next time if you see that, it's not that you are confused, it's null, Na, no. NaN means not a number, simple. Then if you, now I'm adding a few more elements to column C. I'm taking true, false, and I'm assigning it to this column called C. Well, okay, done. So we have created column A, B, and C, which were initially empty. And then I've filled numbers in column A, alphabets in column B, and some string entries in column C. So column B and C, everything is filled. Now, if I want to delete any specific column, then what do? You can say, go to this data frame dot drop out, school dropout, college dropout, in that way. You're dropping off. Okay, you're dropping off this A. And you're saying access equal to 1. So you're dropping this particular column. Instead of the row, you're dropping off the column. Okay, you're assigning that to an object called Y. So drop this A. Access equal to 1 means you want to drop the column. When I say access equal to 0, we want to drop off row. Okay, access equal to 0 means row. Access equal to 1 means you want to drop the column. 0 row, 1 column. Remember in that way. So I'll run this. And now I assigned this to an object called Y. Let me see what is there in Y. Yep, A got deleted. Now only we have column B and column C. Okay, now there is also a specific dataset called MBA. I'm personally not a great fan of that. So I'll import education as X. I'll import the dataset. Okay. Now you have X. which has been imported. Okay. Now when I say go to X and drop certain index numbers, let's see how it works. So I'm saying X is the name of the data set. I'm taking X dot index and access equal to 0. Okay. If I say X dot drop, from X you want to drop. What do you want to drop? I want to drop the index numbers 5, 9, and 10, and I want to choose access equal to 0. Access equal to 0 means, is it rows or columns? Let me quickly put it here. Access equal to 0 will refer to which of the following in a data frame, rows or columns. Please, can you answer this? Wonderful. Y'all are saying rows. Okay, so let me go here. And you all are right. Whoever is telling rows, it is right. When I say axis equal to 1, it is columns. When I say axis equal to 0, you're referring to rows. So at this point of time, not this, X, right? At this point of time, we have index number 0, 1, 2, 3, 4, 5 in that way. And you have 773 rows and 3 columns. Out of 773 rows, I want to delete row number 5, 9, and 19, right? So you want to get rid of 5, 9, and number 19. You want to get rid of that. So let me run it. And you get X. Look at that. From 773, it became 770. So you got rid of 3 rows. Axis equal to 0. Then this is another way of creating a data frame, okay, wherein I'm coming up with a column name, and at the same time I'm also saying that I want to add that column with these elements. Earlier, what did we do? We first created blank columns and then we added elements into each and every column. Here, using a single line, we are doing this. So I'm saying A, which is series of all these numbers, and B is going to be series of all these characters, and then you have column C, which is series of all these numbers. PD is pandas. Pandas has a specific data type called series of numbers. So I'll run this. Now if you look at X, it's a dictionary now. This dictionary has to be converted to a data frame. Remember data frame, like photo frame? Only then you can see the data properly. And then I'm assigning this to an object called new underscore X. So you have new underscore X here, which has all these columns. Now if you say X dot keys, keys means it's going to refer to, where is X? Yeah. These are called as keys. A, B, and C are called as keys. And when you say X dot values, you want to know the values of those keys. Lock and key, right? In that way, this is a key. And what is there in that key? These numbers. So you get those numbers here. What is there in B? All these. So you get those. What is there in C? You have all those numbers. You get that. Okay, in that way. Then, if I say X of A, again we know the same thing. This will refer to the column, and that column has all these numbers. Or you can say dot A. I'm now going to this. new dot x, I'm saying dot a. Dot a would refer to this specific column. Dot a. Okay. And finally, we have a lot of other packages which exist, but then I'll just avoid that part, and I think we'll stop here. Let me give it to our team, but then before that, we need to understand on what we have discussed today. What did we discuss today? We discussed about, let me go back here. Okay, mathematical foundations. In mathematical foundations, we first dealt with um, basics of calculus, in which we discussed about derivatives, in which we discussed about all those rules such as power rule, constant rule, right? Sum rule, then subtraction rule, quotient rule, then yeah, chain rule, many rules. And then what did we do? We discussed on how to find the critical value. After finding the critical value, how to determine whether the critical value is minima or maxima. Here, for minima or maxima, we looked at the second derivative rule for a single argument. If you have a single argument, this is how you solve it. And then if the value is negative, then critical value is maxima. If the value of the second derivative is positive, then critical value is minima. Okay, then we looked at handling two arguments. Two arguments or greater than two arguments will follow the same rule. First, what do? Find the critical value by equating first order direct first order partial derivative to 0. Then find the second order direct partial derivative. Then find the second order cross partial derivative. Then what do after doing this? You find the Hessian determinant. Okay, once you find the Hessian determinant, which will be like this: F11, F12, F21, and F22. You find the D value, which is just cross multiply and subtract, which is F11 into F22 minus F2 into F21. You anyways, these two will be the same according to Young's theorem. You'll get a number, right? So, and this is called as A. So A is nothing but F11. And then we found the rules. If D is less than 0, then critical value is saddle point. If D value is greater than 0 and A value is also greater than 0, then critical value is minima. If D is greater than 0 and A is less than 0, then critical value is maxima, right? This is how to solve it. Okay, now our team is going to handle your queries, and this is the LMS, whatever you have. Now, Enoch, are you there? Team, are you guys there?
I'm here, Barney.
Yeah. So you might want to address this attendance, YouTube link, and also you have to take that. You have to give the price, right? I forgot. You might want to take over and do that, Enoch.
Sure, Barney. Let me do that.
Yeah, wonderful. So there are questions. I'm handing it over to you. You can take it further.
All right.
Yeah.
So
Thank you all so much. Tomorrow, the first algorithm, we will get started.
So, all right, guys, let me quickly share my screen. So you can see that on the sticky note, we have pasted the attendance link. So if you would like to give your attendance, which I would recommend, please go ahead and click and give the attendance. And what we are going to do right now is we are going to pick the winners of yesterday's quiz. And like always, it's also going to be completely random. So we can see the serial number starts from serial number 1 and it goes all the way till serial number 294. So what I'm going to do is I'm going to go to google.com.
Can I give you a call in 2 minutes?
So here I'm going to type in random number generator. And my range is number 1 till number 294. 2, 9, and 4. So the moment I click on generate, there will be one number that comes up here, and that person would be the winner of today's lucky draw. So without any further delay, let's do this. 3, 2, 1, and go. So it's number 26. So let's see who that lucky person is. Number 26. That is Srinivas Rao D. Mr. Srinivas Rao, congratulations. You are the winner for today's lucky draw. And one of our team would contact you and give you further information on how we are going to do this. Congratulations once again, and thank you so much everyone for attending the session. And here's the link, and as usual, we are going to post the quiz links within our WhatsApp groups in maybe next 10 or 15 minutes. All right. Thank you so much, guys. Have a good evening and have a good day. Bye-bye.